Hello. In the last lecture, we discussed about the Ampere Circuit Law and its application on a state conductor. And I told you about the solenoid. In this lecture, I will discuss the how to find out the expression of a magnetic field in a solenoid using Ampere Circuit Law and the magnetic field of a toroid using the same law. Now let us start. It is an insulator over which the wire is wound. I is a current flowing through this solenoid, and to derive the expression of the magnetic field, we have to consider a rectangle PQRS. We consider the closed loop in such a way that it is half loop is inside the solenoid and half loop is outside the solenoid. The side PQ is equal to A. The magnetic field inside the solenoid is uniform and the magnetic field outside the solenoid is very weak, and we consider it almost zero. Now we apply the Ampere Circuit Law to this solenoid. It is the Ampere Circuit Law, and it is the mu naught times the total current in this loop. Now this can be written as for the conductor PQ, QR, RS and SP. Now for the conductor PQ, magnetic field and the current element PQ and magnetic field both are in same direction. It means theta is 0 and the value of the cos 0 is 1, and this length, integration of this length is the length of the conductor PQ, which is equal to A. So the expression is BA. Now for the QR, as the magnetic field is in this direction and the conductor is in perpendicular direction and the value of cos 90 is 0, so this is 0. Similarly for the conductor SP, the angle is 90, so this value is 0. And for the conductor RS, which is outside the solenoid, and outside the solenoid the magnetic field is 0, so this is also equal to 0. So the right hand side expression, that is B dot dl, is equal to BA. Now let us see for mu naught summation I. First, talking about the total number of current. For this we have to find out the total number of turns in this rectangle. Let n is the number of turns per unit length and A is the length of the conductor. So total number of turns in a rectangle is n into A. And current passing through each turn is I. So the total current through this rectangle is NAI. Now equating the equation number 1 and 2. This equation mu naught Ni, and this one, it will give you BA. AC E cancel and it will give you B equals to mu naught Ni. We use mu naught if the medium is air, if the solenoid is air core. If it is not an air core solenoid, then mu naught is replaced by mu. That is the permeability of the medium. Now let us do some numericals. A solenoid of length 1 meter has a radius 1 centimeter and is made up of 1000 turns. It carries a current of 10 ampere and we have to find out the magnitude of the magnetic field inside the solenoid. So we use this relation. N is the number of turns per unit length of a solenoid and capital N is the total number of turns. L is the length, so this will be the relation between the number of turns per unit length and the total number of turns. Here the total number of turns given is 1000 and length is 1 meter, so N is equal to 1000. I is 10 ampere, just put all these values and you will get the result. Second question, here the solenoid is 2 meter long. It has 5 layers of 1000 turns. So total number of turns is 5000. And the value of the small n, which is equal to capital N upon small n. Capital N is 5000 and the length is 2. So the value of the small n is 2500 per meter. Put the values and this will be the result. Now we discuss about the toroid. It is the toroid is shown. Toroid is nothing but it is an endless solenoid. Now see, it is a hollow circular ring on which the large number of turns are closely wound. Red color is a toroid and green color is a magnetic field inside it. It moves in the direction of the current and the green color is the direction of the magnetic field. This one is the direction of magnetic. Now we will derive the expression of the magnetic field due to a toroid. I current is flowing through the toroid and we choose a current element dl in this toroid. B is a magnetic field and the direction of the magnetic field and the current element is same. O is the center of the toroid and it is at a distance r from the current element. Now at this point, the magnetic field is equal to 0. As already I told you, toroid is a endless solenoid and you know the magnetic field outside the solenoid is 0. So we can say that the magnetic field at the center is 0 and as well as the magnetic field in this region is also 0. Now we will find out the magnetic field inside the toroid. Again we are using the Ampere Circuit Law. It is the Ampere Circuit Law, that is the line integral of the magnetic field over a closed surface is equal to mu naught the total current. As magnetic field and the current element is in the same direction, so it is 0. B is tangential and is constant, so it is taken outside the integral, and dl is the circumference of this circle, which is equal to 2 pi r. Now consider the right hand side. Right hand side is the mu naught into the summation of currents. I is the current through the single turn and the total number of turns in this closed loop is equal to the number of turns per unit length into the circumference of this loop. Now comparing equation number 2 and equation number 3. 2 pi r is cancelled and this will be the final expression. Thank you and have a